looking at systems, and they start trying to assess the status of systems in order to identify things that are going to need some kind of maintenance or repair. Just the nature of that work and how you collect that data is inherently, historically, a very human-driven, no surprise, right? I need somebody to go actually do that work. But there's a lot of data that gets collected, and it's inherently prone to the classic problem of human mistakes. I transpose the number.
Is that because there's different people doing the work?
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
On this episode, Embracing Tactical Data Management with returning guest, retired Rear Admiral Ron Fritzmeyer.
Ron, welcome to the show.
Thanks for having me, Darren.
Hey, Ron, you've been on the show a couple times. We love talking. I love talking to you. You're so knowledgeable. And it's good to have another person that understands the government space and solution architecture like you do. So I appreciate that, Ron. And a good hire for Intel was Ron, one of our superheroes, for sure. But Ron, let's dive right in. Let's dive right into today. We're going to talk about data management across the tactical, across the enterprise, and how there's frankly just a lack of it. Is that how you would put it?
Yes. And especially in some of the tactical world and what I've experienced in DoD, and it's not that it's unique to DoD, it's that I'll say DoD uniquely has some of the areas of use where getting into how you manage data is, I'll say, more challenging. And so I've just seen a lot of that. And so I love the idea of talking about how do we take advantage of ways to improve data management. And this is like the whole life cycle, right? So from birth to death, so to speak.
So you brought up an interesting point. When we talk tactical, that's really a DoD thing. In the enterprise world, it's my IoT space. It's my operational technology space that we're talking about. Same problem, though, right?
Same problem. I guess what I see as a distinct element, and again, it's not unique to DoD, but it might be, I'll say, unique by degree, is when we talk about using data as a strategic asset, the first question that you got to ask is, how am I acquiring my data? And so in a lot of today, I'll say classic IT enterprise systems, the data is typically, in many cases, created or generated as part of the IT process. And so there's sort of an inherent trust, which may or may not be deserved, but nonetheless, in terms of how the data is created, the format of the data, and those kinds of things. So there's a relative controlled space already in terms of how you generate data. In a lot of the tactical world, where you're talking about actually handling equipment and gear and all of the heavy use of the main thing we have in systems, which is the people, right? You have lots of different ways that you can potentially create data. And so as we have moved into this world where we recognize that data really is the strategic asset in almost any enterprise, and I mean that in terms of endeavor that we take on, right? The challenge becomes, how do you ensure that you're actually creating or collecting data in a way that maximizes your ability to take strategic, analytic advantage of that data? And for many cases, if it's like, I'll say, human generated, we historically are just not very good at ensuring that the nature of that data is, well formatted, consistent, quality, and I could run through all kinds of examples of those challenges.
Yeah, let's talk about that a little bit. So the first thing is the data generation, because you talked about the life cycle. So it's the data generation is the first one. How can I establish some level of trust? And for me, trust is not an on and off switch. It's a continuum, right? How much do I trust something? Is that the right attitude to have towards this? Or where I'm going with that, Ron?
Yeah, so I think of trust in terms of as more of a security term, which is to say the data, if I think of just now, you give me some data from whatever system or whatever activity, how can I have confidence that that data is the right data, that's not had something happen to it, whatever it might be. But there's an aspect to it that isn't so much security as in what's the very nature of how the data is collected. So if I may, let me give you an example, right?
Okay.
I'll use a Navy example. No surprise, right? Everybody understands at some level that the maritime environment is an absolutely brutal, challenging environment to survive in. So when you put a ship to sea, and I live here in a community of a bunch of yacht owners, right? And it's amazing to see how much work and how much time and how much money goes into taking care of those little boats. So imagine what that looks like on a destroyer or an aircraft carrier, right? It's a really, really challenging thing to say, how do I maintain this system of systems, and how do I understand it? So classic situation is when a ship is coming back to off of deployment to home port or to a shipyard for some kind of maintenance cycle, right? The first thing you need to do is, because it's usually a lot of work, no matter how small or big the maintenance effort's going to be, it's big by definition, right? And so there's a lot of work to prepare for that activity, right? Because there's all the logistics of making sure you get the right kind of materials, the right kind of skills, peoples, all those things. And so there's oftentimes when a ship is coming back to port or back for a maintenance period, there's a lot of measurement and analysis that is done on that ship, even as it's basically returning. But that means it's still at sea. So there's the classic way of you send out a team of people, right? And they go out with their clipboards and their, I'll say their measuring rods and their pens and pencils and a couple of screwdrivers, and I'm being a little bit silly, right? But and they start looking at systems, and they start trying to assess the status of systems in order to identify things that are going to need some kind of maintenance or repair. Just the nature of that work and how you collect that data is inherently, historically, a very human-driven, no surprise, right? I need somebody to go actually do that work. But there's a lot of data that gets collected, and it's inherently prone to the classic problem of human mistakes. I transpose the number.
Is that because there's different people doing the work? Or because one person can't go over a whole ship, so right. So there's the human factor in there, is that we all have different perceptions of things, and some person may be more detailed than another person, or whatever the case may be.
So what I'd say is that the progression would be from just sort of the training of the human, the attention to detail. But let's face it, human beings were imperfect by definition, right? So
right. And we're highly variable too, right?
We're highly variable. So we do the best we can with that data collection process. But it inherently is going to have, if it's hardly any at all amount of data, it's inherently going to have some kind of human mistakes or potentially misunderstandings. You bring up a good point. I've seen this in some of the construction yards. I won't name names, right? But they talk about, depending on the size and complexity of a job, the team lead for that task may be a quote new journeyman, maybe a 5-year journeyman, maybe required to be a 10-year, 15-year master craftsman to be the lead for that task because of the complexity. And if they don't have that, the relative lack of experience and skill in dealing with whatever that problem set is, if you will, they're concerned that it won't be done without too many errors, right? So
here's a question I have around this, right?
Yep.
Because if we took humans out of the loop,
right?
All right, and now I have cameras and drones that are doing everything for me. Does my variability in data collection go down? And maybe it's fidelity is the right word instead of trust. The fidelity of the data collected, does that go up?
So what we saw specifically, because while I was, now this is a handful of years ago, right, when I was the chief engineer out at what's now Navwar, we were doing some work on this very issue, and we actually brought on board LiDAR scanners. Now, using LiDAR scanning, we actually were able to collect much higher fidelity data on aspects of the ships with much higher accuracy, much lower error rates by definition, right? But that only answered part of the problem. So when I think of data management in that kind of a sense, when you move it, I'll say all the way out to the edge, I think of it as being, do we understand where we can automate sort of sensing and collection of data, the LiDAR measurement being an example of that. But also, what are those things that we can do to take advantage of the fact that there are still some jobs where we don't know how to get those jobs done without a human being part of that collection activity. So what can we do to ease that and to reduce the error rates and to improve the fidelity, if you will, of that data? And that's kind of where, my experiences through this space, that's what it drives me to think about. And that environment where you have to have the human in the loop for part of that work. It's different than if you move back into, I'll say, the sort of the more generic IT enterprise world where you kind of generate the data as you go. And so as long as you're confident in your algorithms and your processes that way, that's fairly straightforward. Then it truly becomes more a data trust through the life cycle, which comes back to your earlier point about
yeah. So I like what you're saying here, because this really applies to anyone with operational technology space or critical infrastructure.
Yes.
There are humans involved.
Absolutely.
I can't put sensors on everything that protects everything. There are going to be some kind of human involved. Why? Because we have an innate ability with all the sensors that we have, which is smell and sight and sound and touch. We can do a far better job at assessing something. And there's this gut feeling inside us too. I don't know how to describe that. When we see something, we can say that something doesn't look right, right? I mean, all of our senses together can build that. So we're still going to need a human in the loop as far as the physical world is defined. At least I believe that's true.
I think that's true. I mean, I'm sure you can come up with some examples where maybe you can completely take the human out of the loop, and there are places, arguably, in that sort of the IT enterprise side where we essentially have. However, when you get into any kind of OT, I think that's the right way to think about it. There's almost inevitably going to be some human aspect to it. So the question in my mind then becomes, besides automating where I can automate and basically take the human out of the loop for that portion, okay, great. What about those places where I just fundamentally can't do it? And what I think to there is some other work that I know has been taken on in sort of like, big industrial environments and so on. And that's some of the augmented reality work. And I saw variations of this, even somewhat short of augmented reality, but I'll say with digital support, if you will, to enable the human to be able to basically take what would otherwise be complex, difficult tasks and break them down to something that's, I'll say, much more straightforward. So in the augmented reality environment, for instance, I saw a great example in a big industrial environment where a technician had to go in and had to identify a specific pump. In order to work on a specific pump, they had to know where certain valves were and to ensure that the lockout processes were correct for how they ensured the valves were in the correct positions for lockout, to be able to then work on the pump, all those kinds of things. They actually were able to use augmented reality. So you had essentially the equivalent of a digital twin of sorts to the industrial environment. And they could walk in this case, with glasses and use augmented reality to actually help steer them and drive them through the process. So you still absolutely had to have the human to, I'll say, effectuate the work, right? But they had the advantage of the system, and in essence, breaking down the decision and thinking process through that to make it easier for them to do that. And I've seen examples, once again, in some of the ship construction work where they've said, having brought in some of these digital processes, their return on investment has been things like, hey, tasks that have historically taken like a 10-year journeyman, we now hand to a guy who's been here only 2 years, right?
Wow.
And with confidence, they accomplish that task. So it is potentially, from a personnel standpoint alone, potentially a huge benefit to how organizations can operate.
So that fusion between the digital twin that can help in this fidelity of data collection, right?
Yes.
So that the human and the machine now work together to give a better way of collecting data. I love that idea because I don't want to be replaced, not completely.
There's a great book, Humility is the New Smart, right? I forget the subtitle to it, but it's basically, people in living in the artificial intelligence age. And the notion being is that, the classic challenge for us humans is we don't like change and we get comfortable in something and good at it. We just want to be able to do that, right? But the reality is that as artificial intelligence in particular is really coming into its own, if we want to be effective as human beings in this process, we need to think hard about how are we position ourselves to do that work that still really requires the human being. In some cases, that's actually an emotional intelligence problem, if you will,
Yes, yeah,
more than it is not just quote intelligence. Sometimes, though, it's actually physical manipulation because we don't yet have those environments where you can automate a lot of those activities, right? So, an example might be brake and inspection of a motor on a ship, as you're saying, okay, I can look at the motor from the outside and I can do some basic tests to say, is it operating? But how close is it internally to needing some major repair or maintenance activity?
No way to tell if it's closed, right?
No way to tell if you start tearing it apart. And today we're not quite at the point in many cases where we can automate via robots and so on. Although some of that obviously is evolving too, that could do a lot of that. But some of that work, I think, today still remains in the domain of human beings. and
I'm glad we need that.
Right?
Yeah.
But we need to be pretty adaptable too. And I've seen that example. Again, years ago, I was involved in a project where we were actually doing some automated data fusion. And I don't want to name names because I don't want to point anybody out. But bottom line, we took it to an organization that this was their livelihood as an analytic organization. And we showed how we could automate some of the early data collection analysis problems. Our thinking is that the analysts are now free to do that higher level of analytical thinking that at the time we had no notion of being able to do it by machine. And the first response that I got back from the team of analysts was, why are you trying to take my job?
Yeah,
rather than saying,
of course.
Thank you for relieving me from this kind of grunt work, because obviously the work that we could automate at the time really was kind of the grunt work. But it's like, we're trying to actually allow you to really do that higher level analysis. And I just could not get people to see that. They were just like,
because they're comfortable, right? They don't want to change. Yeah. All right. Hey, we got data collection, the birth of data, right? What happens next if we talk about the life cycle? What happens next?
So again, experience says, because we rarely start, I'll say in the greenfield sense, with a system of saying, okay, how are we going to collect the data? How are we going to manage the data given it's collected? And that's where the issue of, I'll say, retaining the fidelity, the legitimacy of the data, the authenticity, making sure that nothing's been modified. More importantly, while you have to worry about it from a security standpoint of people trying to, I'll say, attack your data, that's absolutely true. But honestly, I think my experience has been that we fall down more in that we're just not managing the data, which is to say we don't know what we have oftentimes, right? We go, well, wait a minute. We collected a bunch of data, but did we understand? And this is where I think the life cycle data management needs to start from the beginning, which is to say, how am I going to use the data that I am collecting? Because if I'm just collecting data, because that looks like something that's useful to collect, but I don't necessarily have a good sense of how I can use it into the future, right, for some life cycle benefit, then chances are I'm not going to handle it in a way that it becomes as available to me as it could be. This gets into the whole debate about how do you tag your data, right?
But also this brings up something interesting. I just interviewed on a previous episode. It actually came out today, the day we're recording, with a data professional, and he talked about specifically that we're gathering way too much data because we don't know what to do with it, right? And he goes, and people are keeping it because they're afraid. What if that data might be valuable? But what you're saying here is the same thing. We need to know why we're collecting the data, right? Because if we're not, then we're just collecting data And that data could actually end up being an attack vector. It could be a gaping hole in our security. There's a whole bunch of things around. Just collecting data because it might be useful in the future is not a good answer. He
Right.
said that as a data professional, and I'm hearing you say that as a cybersecurity and data specialist. So there's something to this. We need to pay attention, it sounds like.
Yeah. So again, I wouldn't encourage people to immediately just start saying, "Hey, I want to shed all my data." What I would encourage is, what are you doing with the data that you're collecting? And actually, at some point
Okay.
in the process, right, kind of an inventory of what. Again, I'll go back to a generic Navy example, but so we had this system that we were continuing to build more and more of them. But what we're finding in terms of operational availability, that number wasn't going up nearly as fast as the number that we were bringing into the inventory. And it was like, hey, this is a problem, right? We're buying more of this stuff, but we don't actually have more generally available to use. That's not a good thing, right? Well, we need to understand why. And what we found out from starting down that path of asking the question why, was, first of all, we collected tons of data. There was not a lack of data. But one, we didn't have good processes in some cases for how we enabled the people who had to do a lot of the data collection, and some of it was manual generation, to make it easy for them to generate, I'll say, good data. So we had a lot of noise in the data based on the collection processes. We've kind of gotten through that.
Right.
But what we also had was we didn't understand well how we were going to use that data. So when it came time to try and start doing the analysis, we kind of had this sea of data, if you will. And by definition, it was collected. So you had some kind of, I don't know that I would say tag, but you had some kind of sense of what it was being collected about, if you will. But it still took a lot of work to basically build the model of where is the process not working well, right? And how does the data speak to that? And so it actually took a lot of time of, I'll say, doing this data investigation in this large lake of data, some of which was very, very noisy, which means sometimes if you went too quickly, you could draw bad conclusions pretty fast, right? But enduring through that for some period of time, we started to see some trends. And as we saw trends, then we were able to identify, so what data is really informing what appear to be those major trends? And from that, we were able to say, okay, now we better understand what data speaks to this particular problem. And then you could focus on it and actually talk about how you could, I'll say, better tune the whole system from data collection through analytics and decision making.
That was my follow-on question was, you've got to take your data investigation back into your data collection. Otherwise, you're still just collecting a bunch of data that is not useful. But then, isn't there a fear, and a founded fear that, well, there might be another use case that comes on, a year from now, where I could have used the data that I've now culled, I've gotten rid of, because I didn't have the use case at that time. How do you balance that uncertainty? Or do you just say, you know what? Too bad. You missed out on the data from last year. I don't know. Hey, Ron, now that we've collected all this data, I've got my feedback loop I'm going through. What do I do? What do I do with all this data now?
Right. I remember some examples of back when I was still chief engineer at Space and Naval Warfare Systems, now NAVWAR, that where we were looking at supporting on the Nav Air side some of their maintenance activities for the F-18 fleet, right? And one of the challenges that we saw when people started saying, I want to take advantage of all the data that we've collected, was they tended to think of it in, I'll say, try to do the whole thing, right? How do I make this data to make my planes and my maintenance cycles as effective as possible? When we went in, we said, start small. You might remember from the, is it the Patriot movie where he says, aim small, miss small? It's kind of like
that's
you're going
right.
after data insights, right? Start small. Have a very focused, intentional question that you want to get answered, and then say, how does the data inform that question? Sometimes you find out you're asking the wrong question, right, as you start going through the data. But if the question is about some performance or process characteristic that you can define and be really clear and specific, you have a better chance then of starting to look at the data, if you will, to say, how does it help me address this question?
Okay, so let me reiterate.
First take,
Yeah,
typically, right?
let me reiterate what I think I heard you say. If I go in saying I gather all this maintenance data, and if my question is how can I be more effective, that's not a really good question, right? Because that's too broad. I'll get stuck into this analysis paralysis. So you say let's pick one specific thing, right? Like the tires are wearing out really quick. I don't know what happens with F-18s. Right. So I focus on one thing first.
Focus on one thing. And in that process, when we went through that, the kinds of things that you learn are one, do I in fact have the data that starts to give me insight to that focused question, right? Two, it also starts to tell you about your data collection process that we talked about previously. In other words, does my data look pretty good, or is there something about my data that seems to have, I'll just say, a high level of randomness to it that says, hey, I need to actually go back now and look at how I'm collecting data. Now that I have an inkling of what data is going to help me answer this question, am I actually doing a good job of collecting the data? And I may have mentioned it before, but the notion of sometimes it's like, not to sell Amazon or anything, but if you go to Amazon, right, one of the things that they measure is how many clicks does it take a person to get to the thing that they care about, that they're going to buy, right?
Yeah, you're right. Yeah, that's a huge thing.
Right? So sometimes from a system collection standpoint, we don't think about necessarily, are we tuning the mechanisms of collection to make it as easy as possible for the operator, given that there's almost always a human involved at some level, make it as easy as possible for the operator to do the right thing, and, minimize what would otherwise be this is so painful, I have to fill out these 10 elements of this form, I don't really understand this one, I'm just going to throw some data in there so I can get the darn thing out of my hair, because the stuff that matters, that person thinks, is already there. So I would say it's an iterative process in that sense of, I seek a very well-defined small problem set. I start analyzing the data. This is the feedback that we talked about earlier, right? I go back and say, you know what? Here are some ways that I can improve my data collection that will improve my ability to get the answer. That's not to say that you won't actually get real insights on that specific question from your data, but you're going to learn a lot about your data and the whole, if you will, life cycle of collecting that data at the same time. And that's what we found, is that you actually improve both ends, if you will, of that data life cycle.
So management is always going to put a lot of pressure to say, I've got to increase the speed of how I'm getting this stuff out. Great, you gave me insight into why the tires are blowing out or wearing out, but I really don't care. They want to know bigger things. So how do you balance that? And is there any ways that we can accelerate insight into and maybe see something that's not, that we didn't have the question up front? How do I address those concerns? Because I'm getting a lot of pressure from management. Right.
So not to change the whole thread of this conversation, but what you just described starts getting into the notion of beginning to build, if you will, the equivalent of a digital twin or digital model of your system, so that your data starts becoming learning about how your system operates and behaves over time. And you can now start talking about how is the data actually informing in a more predictive sense, right?
Okay.
Why? Okay, I can measure the fact that my tires are getting burned out quicker. Why is that? So for instance, is this consistent across pilots, across platforms, or what are the relationships, if you will, of the data and these other factors? So this is where that very specific question now starts kind of building out to the secondary and tertiary, if you will, points that allow you to begin to differentiate what's the data really telling me. So, right, it's almost like you can either think of it as burrowing in or backing out and saying, do I have a bigger picture of it? But I actually prefer to think of it as burrowing in and refining what I know about that initial question that I asked. What's the life cycle, in this case, using your example, what's the life cycle of my tires, right? What informs the life cycle? What are things I can change? So I'm not going to use tires, but I will tell you from a maintenance standpoint, one of the things that we learned is that there are certain components that when they go bad, right, the test cycle for repair of those components has leakage, which is to say it's not 100% good. So if you send a part back for repair and it comes back having been repaired, it may still fail. There's just I'll say some leakage in that process.
Gotcha.
That drove us to say, do we understand the leakage? And in some cases, because of the nature of how it's contracted, it became too hard to actually drill all the way down that path. But the data said the following things. You can actually identify a lemon part, which is to say, if it's been returned twice for repair and comes back and still doesn't work,
throw it
cheaper
out.
to throw it away
Yeah.
and just get another one. And it actually costs you less money in the end game, and it actually speeds the maintenance process, right? By identifying those lemon parts, if you will, earlier in the game.
So it sounds to me like the more we start with a simple question, the more data we get that helps answer that question, we dive deeper, we burrow, so we can get more insight the more intimate we come with the data. So it takes time. That's what it sounds like. It takes time. Is there anything that you see on in the future horizon, maybe generative AI, in combination with building these AI models? Do you see that accelerating this process?
Right.
Or is it just we just need to become really intimate with our data? Do you see where I'm going with that? I'm trying to uncover this.
Right. Yeah, I think the answer is going to be that AI can actually help us speed that cycle of learning and burrowing into our data. But I admit that I'm projecting, and I'll give you.
Yeah, well, yeah, I'm wanting you to project a little bit. Yeah.
Right. Right. So decades ago, more than 30 years ago, I was working a problem where I was working with a failure analysis team, and we had a very, very skilled team. I mean, I was the junior guy on the team. At that time, I had maybe 5-7 years experience in that particular field where I was working with this other group of folks. But among like 5 or 6 of us, we probably had, well in excess of 100 years of experience doing failure analysis on it was microelectronics actually. And what we were asked to do was to support the failure analysis of a government shop that said their challenge is that they typically didn't keep somebody in the shop doing that work more than about 3 or 4 years. And so they said, we're habitually short on experience in this role. Help us understand how to take your, relatively massive experience and boil it into something that will allow us to operate, in an advanced state, if you will, with these folks who don't have that same level of experience. Again, this was back in the early 90s. Boy, it would have been great if AI had progressed to the point where it has today.
Oh, yeah,
right?
yeah.
Because I could just imagine how that would have changed the game. But what we tried to do was sort of the poor man's equivalent of that, of trying to write out essentially, take this step, do this analysis, and you're probably going to find your response will fall in one of these 4 buckets. Depending on which bucket is, here's the next best step to take as you kind of continue to go through your process of doing this failure analysis. So we tried to write out something that would look a little bit like a failure analysis algorithm, basically, right? And in providing that, it was great at the time because it helped the team operate more effectively, but it was heavily manually intensive. And so when you start talking AI, the wonder of AI is that you're in a place where your machine can actually typically recognize subtleties, and frankly, against large data, just trends, much faster than a human being can typically pull out from a basic analysis standpoint. So it's arguably one of the best areas in my mind for bringing AI in, especially when you start talking anything in terms of national security, where I don't really want AI making decisions for me, but AI can definitely inform decision making faster. So in the classic sense of the OODA loop, right? Observe, orient, decide, and act. I see AI having a great potential to speed the front end of that loop so that you can get the decision and action much, much faster and much more richly informed because of using something like AI to work your data.
And you know what? I found that in a recent, I just finished up my dissertation and I had gobs of data.
Congrats.
Oh, thank you. Thank you, Ron. But I found that the analysis I originally did, the subject matter expert said, that's the wrong analysis. And I was pulling my hair out. And so I took my data set and I dropped it into ChatGPT and I said, how would you analyze this? What techniques would you use? And it gave me like 4 or 5 different techniques. And I said, all right, I'm going to try each one and see what the results are coming out and compare and contrast. And so I was able to run this through very quickly and got the best. I ended up doing linear regression because that seemed to be the best fit for the type of data that I had. And the results were great because of that. So I see how you can use AI in that analysis deep dive that you're doing to help with building the analysis of the deep. You know, it's almost like some people are afraid because I've got AI telling me how to use AI. I guess. Does that make sense?
Right. So you know, I read a book a handful of years ago that talked about this notion of, you know, being data driven. And it started out by discussing the notion of what today we would often call graybeards, right? Somebody who is an expert in their particular field. And I remember an example years ago of a good friend of mine who was talking about they raised show horses. And he said they talked about what it was like as a judge to basically assess any given horse. And,
right.
And they took like 3 renowned judges and asked them to judge a set of horses, and they came up pretty consistently. But then when they went back and they asked them to say, so can you name and prioritize like the top 3 characteristics
they couldn't
that
do
drove
it.
your answers? It was all over the map as far as each one of them had a sort of a different, seemingly different set of things that they were looking at. I mean, there was obviously some commonality, right? But it was interesting. And in this book, it pointed out that human intuition is very powerful, but rarely correct. A little bit of data dramatically benefits intuition in making much, much better decisions. I just thought it was, absolutely intriguing. I'll just, based on the number of examples they gave in the book, I'll just sort of accept it as that they proved it in my mind at least. But I thought it was a really interesting point that, so to me, AI is not about making my decisions. It's about helping me be much, much better informed and make those decisions more rapidly. And then sometimes in a situation where either there's so much data or so little data that I otherwise would just be, whistling in the wind, so to speak, trying to figure it out.
No, I love how you said that. And that's how I've seen it because I use AI a lot, Gen AI a lot, and it's just helping me make better decisions. It's presenting data. It's giving me data in different formats that I can consume more easily. So I get that. Ron, it's been great having you on the show. We're going to have you on again. We got so much to talk about, but our time's up today. So
Good.
Thanks for coming on again, Ron. I appreciate it.
Thanks for having me, Darren. It's been fun chatting.
Information today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about embracing digital transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.